All right, we have another change of variables problem here. And we're going to go ahead and do it. We need to put this in the right form. So y prime minus 5y equals e to the minus 2x times y to the minus 2. Sorry. Here n equals negative 2, right? That's this value right here. So we have our n, and that tells us what we want to do for our substitutions. We want u to equal y to the 1 minus n. That's y to the 1 minus negative 2, which is y cubed. So we're going to have u equals y cubed. The inverse of that is that y equals u to the 1/3. So keep that in mind. Our derivative of that, u prime, is 3y squared y prime. So y prime is 1 over 3y squared u prime. And let's go ahead and plug back into our differential equation now. So y prime is, well, let me write this differential equation again where we can see it and work with it. So that's just a reminder of what the differential equation is. And our substitution looks like 1 over 3y squared u prime minus 5. What is y? Y is u to the 1/3. U to the 1/3 equals e to the minus 2x, y to the negative 2. So that is u to the 1/3 to the negative 2. So we got some exponents to deal with. We almost have this all in terms of x and u, but we have this y hanging out right here with the y squared. So what is y squared? Y is u to the 1/3, so y squared is u to the 2/3. So our final piece of replacing here is 1 over 3 u to the 2/3 u prime minus 5 u to the 1/3 equals e to the minus 2x. This is u to the minus 2/3. We're going to multiply everything through by this u to the 2/3. Let's multiply through by the 3 as well. So we end up with u prime minus 15. It's 5 times 3. U to the 2/3 times u to the 1/3 is just u, equals e to, I forgot the 3. So 3e to the minus 2x. U to the 2/3 times u to the minus 2/3 is 0. And this substitution has worked out nicely, which it will if we do it correctly. If we do this chain rule correctly and the derivatives correctly, it's going to work out nice. It's going to feel like magic. So we now have a linear first-order differential equation. At this point, we could use the method of undetermined coefficients, or we can use the method of integrating factors. Either way, if we use the method of undetermined coefficients, which we can because this is a constant coefficient linear differential equation. The coefficients are constant. In the previous example, that wasn't possible. But the method of undetermined coefficients tells us we have our homogeneous solution, which is going to be e to the 15, ce to the 15x. And our guess for our particular solution is ae to the minus 2x. So I'm choosing the method of undetermined coefficients mostly because the right-hand side here gives us a really easy guess, and this seems like the right way to go. So y particular prime is minus 2ae to the minus 2x, and we plug in, I guess I should have been using u's instead of y's, but whatever. Minus 2ae to the minus 2x for the derivative, minus 15 times u itself equals 3e to the minus 2x. So we have minus 17 ae to the minus 2x equals 3e to the minus 2x. So a equals -3/17. And we have our solution. U is the homogeneous solution, c e to the 15x, minus our particular solution, 3/17 e to the -2x. And we do want to substitute back, so u is equal to y cubed. So this is y of x cubed equals c e to the 15x minus 3/17 e to the -2x. And finally, let's plug in our initial condition here. It was y of 0 equals 2. So y of 0 equals 2. If we plug in a 0 for x and a 2 for y, we get 2 cubed equals c e to the 0 minus 3/17 e to the -0. So that's 8 equals c minus 3/17. So c equals 8 plus 3/17. 8 times 17. Let me look that up really quickly. 8 times 17 for the common denominator is 136. Plus 3 is 139. So c is 139/17. And our final solution is y of x cubed equals c, so that's 139/17 e to the 15x minus 3/17 e to the -2x. So that is our solution. It's implicit because it's a y cubed on the left-hand side. If you want to take the cube root of both sides, that works out just fine. You can take the cube root of both sides. Kind of like leaving it like this without the cube root, but either way will be just fine. So that is our change of variables technique on a second example.